Hey folks, Darren with Fervent Astronomy. It's maybe an understatement to say that a 20mm lens is a favorite of astrophotographers as well as landscape photographers. And I'm a real fan of when you can take a lens and use it for a wide range of things. Of course, astrophotography being a major part of Fervent Astronomy's business, wanted to take a look at one particular 20mm lens. Now there are a lot of 20mm lenses on the market, wide range of focal ratios. You have f2.8, you have f2, you have f1.4, but today I want to take a look at the Sony G 20mm f1.8. This is not part of Sony's GMaster series, sort of the highest of the high that they have, but it is pretty much the same build quality, so I'm really interested to take a look at this lens. I do have a ton of different cameras from different manufacturers. Just so happens that Sony has a lot of cool lenses, and let's take a look at it. So this particular lens has a physical aperture ring. It is declickable. It's got a programmable button, an autofocus and manual focus switch, which with me it's always set to manual focus. Of course, here we have the front element. You can see it's got a removable petal hood and a normal filter thread, so you can put your filters on if you're going to use it for video and you need polarizer or a ND filter or something. But yeah, so this should be an interesting lens. I'm out in the mountains really hoping for good weather to see if we can take a look at the corners of this lens, how flat the field is, and see if it's really worth it. So if you hear from me again and you're watching this, that means the weather worked out and I'll have some samples for you. Okay, so we're going to be using the Light Track 2 from Fornax Mounts to track things for our test. Fervent Astronomy is North America's Light Track, or rather Fornax Mounts distributor. That includes the Light Track. Here I've got the base mount, the Light Track set up with the FMW 200 wedge. Not a necessity, it's just a convenience. The mount through the back can actually be mounted via a regular tripod head. I have an optical poloscope set up because I'm old school. I've got battery pack, just a rechargeable lithium battery pack, 12 volts, Velcro to the bottom. Do sell these as an accessory when you buy your Light Track 2. And last but not least, I actually have a Manfrotto quick release thingy here. What is it? They call it their Manfrotto Move. But I like it because I can do this and lock it, and it's super solid. I took it apart and there's these 3 bars in a triangle configuration that clamp in, so it's pretty good. Let's get going. All right, welcome back. Now I say welcome back because I'm time traveling a little bit. It's actually been 2.5 months since I recorded that intro. If you're curious, the weather worked out great, but as you can tell by this very blue looking photo, the samples did not. I'm up here in Canada. I was trying to take photos around the summer solstice, and that means that it's blue hour all night long, every night for a couple of weeks on either side of the solstice. So I went back to the mountains multiple times to get proper samples for you. Don't cry for me, dear viewer. I was willing to make the sacrifice for you because you are important to me. And as a result, we have a bunch of stuff to show you. We've got a set of samples taken with the 50 megapixel Sony Alpha 1. These are untracked photos on a tripod. I've got some samples here taken with the 61 megapixel Sony Alpha 7R Mark IV, and those are tracked with the Fornax Mounts Light Track 2. So there's a lot of good stuff to show you. A couple things I want to note up front. The samples will be available for download. Look in the description for a link. Please download them pixel peep to your heart's content. Process the files if you want to see if they have the processing latitude that you personally need, but as the copyright holder, I must insist, please do not misrepresent them as your own. Please do not post them on social media or anywhere else. Please don't enter them in any photo contests. Please do not use them for any commercial purposes whatsoever. These are merely here to help you assess whether this is the lens that you need to have in your camera bag. Now, one of these cameras, the Sony A7R Mark IV that I'm using, is actually full spectrum modified, and I use a series of Colari Vision clip-in filters to change the types and amounts of light that make it through to the sensor. But for the purposes of this review, we're going to just be using a stock white balance filter, so it's going to appear exactly as any stock A7R Mark IV. However, if you are interested in watching that modification, I do have a video up on the YouTube channel for you to take a look at. One thing that I want to draw your attention to is the fact that every photo taken with the A7R Mark IV is going to be at ISO 320, and every photo taken with the Alpha 1 is going to be at ISO 500. And you might ask yourself, why is that? Well, I will demonstrate that here for you. It is because of a phenomenon known as ISO invariance. Essentially, both of these cameras, coincidentally, only have two real ISO values. One at ISO 100, and in the case of the A7R Mark IV here, one at 320, and the Alpha 1, its second ISO is at 500. What that means in practical terms is if you look at these two photos, one of these is taken at ISO 320 and one of them is taken at ISO 2000. And I would challenge you to find any difference between these two photos. The noise is the same, the color reproduction is the same, the overall quality is essentially identical. Were it not for the black line separating them in the middle here, I doubt anyone could really tell the difference between these two. And that's interesting because one of these photos looks like this right out of camera. This is the one taken at ISO 320, and all the camera is doing to get this photo on the left here is it's applying digital gain. It's using the exposure slider essentially to match the appropriate brightness that it would need for that ISO value. To demonstrate this a different way, let's pop over to the website photonstophotos.net. It's a great website full of lots of nerdy information about camera sensors, and we're looking here at the read noise in deigned chart. This plots read noise versus ISO, and I have the A7R Mark IV selected. They've got pretty much every camera under the sun on here, and we're gonna look here. We have ISO 100, a flat portion, drops down to ISO 320, and another flat portion. And an ISO invariant camera will have a linear graph on this particular chart, and 320 and 100 are, of course, those two base ISOs, the two native ISOs in the camera. And all the camera does to get these other ones, as mentioned, is it scales them digitally. This demonstrates one important part here that is good to know, though, and that is that there is a switchover at ISO 250 to the second analog to digital converter at ISO 320. And that will give you lower noise with higher sensitivity as compared to using most of the ISOs right here. I mean, all the way down to ISO 125 is pretty much the only one that you're going to get a better noise profile with. So if you're going to be shooting in this particular area, it makes no sense. You're better off dropping or bumping the camera up to ISO 320 because you can get lower noise and higher sensitivity. Now, all of these particular values all the way up the graph are, I know it's hard to believe, just digital gain. These are simulated, but what happens when you select one of these values, like ISO 2000, is that you lock yourself in to the exposure, you lock yourself into the noise, you lock yourself into any blown highlights, etc. And if you choose to instead shoot at the base ISO with the same exposure time, with the same aperture value, you actually get a little more leeway. You aren't locking yourself into as many things if you decide that you actually wanted to only be at ISO 800 later on. So that's why I shoot here typically, and that's why I would encourage you to look up your camera and see if it is a similar situation. There are non-invariant cameras. I'll just show you one really quick. I know for a fact the A7, or no, the Canon 5DSR rather, you can see here, it has a more gentle slope to its graph. This is a non-invariant camera. For each of these ISO values, there's a different relationship with noise. These are not simulated in camera, so you're going to want to be closer to the real ISO value that you want to get the exposure that you need. Another thing that I really have to mention, you cannot compare cameras across to each other. You cannot say that the noise in this camera is much higher than the noise in this camera. That's not how all this works, and it says somewhere as such down here, but you can compare a camera's own noise values to itself versus ISO to see where the right choice for you would be. And for me, for this camera, it's at ISO 320. For the Alpha 1, it's at ISO 500. I'm probably going to make a video explaining this in more detail at some point, but if you're watching this lens review, you are more than likely using a Sony camera, and there's a good chance that your camera is ISO invariant like this one. Let's pop back over to Lightroom and get into the samples. First, we're going to look at the untracked samples taken with the Alpha 1 50 megapixel camera, and we're going to zoom right into 400, and you can see right off the bat we've got a lot of star trails. Even though we're at a 20 millimeter lens, even though we're only at 15-second exposure, we have a really high resolution camera, and that's resolving a lot of detail, and that is making these star trails show up nice and prominently. Now, zooming out, is anyone ever going to notice on social media? Doubt it. At 100%, is anyone really ever going to notice? Even if they're looking at a, let's say, an 8x10 print or something? Doubt it. But, this is what you can expect. We have a really high quality glass, really high resolution sensors, and that results in every little thing being shown in sometimes horrific detail. One thing that this does do, though, is it masks a lot of the aberrations, so you don't have to deal with that. So that's a nice plus, minus the vignetting here, which does clear up around 2.8 here, as you can see. It's pretty clean, but you don't buy a 1.8 lens to shoot at 2.8. As we can see here on the histogram, there's space left on the left. We're not crushing the blacks, and there is a little latitude, so you can use the lens profile for this lens and it will remove the vignetting, and you're going to have perfectly nice clean corners unless you underexpose and start clipping the blacks there. But for this particular case, 15 seconds, it worked out pretty well. Might even be able to shorten that down a little bit to shorten these star trails, but you know what? I think that's perfectly usable. That, however, doesn't show all of the aberrations, so we're going to go down to these particular photos taken with the Sony A7R Mark IV, 61 megapixels, tracked with Light Track 2 for 60 seconds, and starting at F1.8, it'll show us all the nitty-gritty. First thing we're going to do here is we're going to go into the center of the frame, and we're going to talk about Sony's spatial filtering, aka Star Eater. What this is an algorithm that Sony uses to remove hot pixels and control noise. And unfortunately, it plays foul with stars, especially small pinpoint stars. It does, for the most part, leave brighter stars alone. And this is because it functions based on a bright pixel surrounded by adjacent pixels of a certain other brightness. So for any of these tiny little stars that we're getting, or dimmer ones far away in the band of the Milky Way, they are appearing to the algorithm as either noise or hot pixels, and it's kind of turning them into various little shapes that are not round but look kind of like film grain. However, the brighter stars, which are bright enough to spill out over multiple pixels, retain their round shape. This is just a fact of life with Sony cameras, and it might change in the future. It's changed in the past, but this is what we've got to deal with. For me personally, it doesn't bother me. I'm not taking scientific observations with a consumer camera. I'm creating artwork, and I would imagine you are as well. There are a couple ways that you can actually counteract this. One way we actually already saw and that is trailing. This is not something that shows up when these stars are trailed even a little bit, because they are essentially avoiding the algorithm. They are no longer a point, they are a band, and so the algorithm leaves them alone. Another way that you can actually counteract this is by defocusing slightly. Here is a photo where the stars, you can see, are a little more disc shaped, and because of this, the algorithm does not see them as noise, does not see them as hot pixels, and it leaves them alone. And for all intents and purposes, no one is ever going to really notice that these stars are slightly out of focus. And that's one way that you can actually get around that. But we'll pop back here and take a look at some more aberrations. So one thing that this lens has is field curvature. Field curvature is a result of the fact that you're using curved glass elements to bend light onto a flat sensor plane, and it's not perfect. And for this particular lens, it's manifesting as the corners being slightly out of focus when the center's in focus. You can see, of course, that we have our Star Eater film grainy look, and then as we move towards the outside of the frame, things get a lot coarser. These stars are a little bit out of focus. They're also experiencing some other aberrations, which we'll talk about, but we can see that they're actually a fair bit bigger, all things considered, versus these ones. And that is indicating to me that what's happening is the center is in focus, but focus is being lost as we go outwards. We're not getting a perfectly flat focal plane, and should we end up focusing on the stars in the corners, in all likelihood, these stars in the center will actually be slightly out of focus. One way that you can get around this and actually mitigate Star Eater, as we just talked about, is you can focus on the stars at the midpoint of the frame, and this will give you the best of all worlds. You'll get more consistent focus across the whole frame. You'll probably be a little defocused everywhere. You'll dodge Star Eater, and that could actually be a boon. So that's one thing that you might want to try. Again, at 100%, no one is ever going to notice. These are really nitpicks, but that's why we're here. We're here to nitpick. Now, speaking of which, let's come in here. We'll zoom into 400. I think this is the star Satyr, and we're going to talk about chromatic aberration. That would be color fringing on high contrast points, such as a bright star against a relatively dark background. And there's very little, you can see maybe a tiny bit of blue. Let's go over here to Deneb. Blue, maybe a little bit. Sometimes there's a little bit of green fringe, or it can be a magenta color, but in this case, wide open, there's very little, if any, chromatic aberration to worry about. And honestly, you can fix it super easy in post. In Lightroom, you just click that remove chromatic aberration check mark, and it'll get rid of it for you usually, or you can use the manual eyedroppers. But anyway, let's go over here to Vega, and here we see a very bright star. It's one of the brightest stars in the sky at the time that I took this, and there's a little bit of blue haze around it, but you can still see stars through that, or either in front or behind it. So there's a little bit of loss of contrast, but overall not too bad. And this is showing that the spherical aberrations are actually fairly well controlled, which they are on most lenses these days. But what it actually manifests as normally, if it was quite bad, would be an area of fuzz, of bloating of the star, of any bright stars, where things would just get really big and hazy. In this case, it's not really a problem. I wouldn't worry about it. Now let's look at the corners. Of course, everyone wants to see the corners, and some of you are going to be thinking right away, coma. But mostly what you're seeing right here are two types of astigmatism: tangential astigmatism and sagittal astigmatism. Tangential astigmatism radiates outwards from the center of the frame, and sagittal astigmatism kind of rings the center of the frame. And that leads to these little fighter jet looking stars. These two kinds of astigmatism are not always found together in the same amount. They are independent. And what's happening here is the lens is having difficulty as we reach the edge of the frame, focusing that point of light in one point, and it's spreading it along these two axes. And one thing you'll note is anywhere you look on the frame, they're always going to be pointing towards center. That's the tangential astigmatism, and the sagittal is going to be making these little wings, and that is going to be essentially at a right angle and ringing the center of the frame. And it is present pretty much everywhere around the outer edges of this frame, and overall, you know, it's quite noticeable if you're out here in the extreme corners. At 100%, you know, you can still kind of see it's got a little bit of an angular shape, but once we're out here, you know, even to the top edge, I have fairly normal eyes and I can't really tell. So whether or not it bothers you is going to be up to you specifically. Now, there is a question of whether or not this lens has coma. And coma, or chromatic aberration, is named after comets, comet tails, that coma that comes out behind of a comet, or that points away from the sun rather. There are two types of chromatic aberration, and they manifest as little bright points stars with little fuzzy tails that come out in a triangular-ish shape typically. And looking here at the top of the frame where the astigmatism is controlled a little bit better, there might be a bit of coma, but it's hard to tell because we're also experiencing that field curvature and we're losing focus on these stars. So is it a big deal? I really don't think so. There's two types of coma, internal and external coma, and they're named as such depending whether the little coma tail points away or towards the center of the frame. And you know, if there is any, this looks like external coma where it's pointing away from the frame, but overall I don't really see this as being much of an issue, and this is wide open. As we mentioned before, this lens does have some vignetting, which we can see here around the edges of the frame, and this does resolve as you stop down, but you can also fix it in post using lens profile corrections, and there is a small amount of distortion as well. I'm just going to pop over the develop module here and take a look at that. Scroll down here and we're going to enable profile corrections, and you can see that it both clears up that vignette and also it is correcting the distortion. So there's a little bit of looks like probably barrel distortion happening in the center, and yeah, easily correctable and really doesn't affect the file much at all as far as these small details go. So that is totally easy to deal with. So now we'll run through the apertures here to give you a little idea about how things progress as you stop down. This is around the center of the frame, 1.8, f2, 2.2, 2.5, and 2.8. You can see start to get a little bit of that diffraction spike pattern, the tines off the bright stars, and we'll just go in reverse, and overall things in the center don't change very much. Now we'll look at mid-frame. This is at 1.8, f2, 2.2, 2.5, 2.8. You can see things don't change terribly much. We'll just, we can note here again, got a little bit of that sun star effect on the star Vega here, little diffraction spikes from the aperture blades, but overall things here look pretty consistent with what they look like at 1.8. Now we'll look at the corners. So this is at 1.8, f2, 2.2, 2.5, and 2.8. And you can see now by 2.8, our fighter jets are looking more like little bullets, or almost like little Pac-Man ghosts flying towards the center of the frame. And this, I think, those little taily bit is showing a mix of both coma and tangential astigmatism there. And you can see the sagittal is mostly cleaned up, but it's not completely gone. It is still visible on a few of these stars, but for the most part, it is cleaning itself up. And again, we'll just pop over to 1.8. You can see that's quite a contrast between 2.8 and 1.8. So if this is something that you do want to deal with, you might find yourself stopping down a little bit. Let's see where it really starts to change for the most part at 2.2 to 2.5. So do with that what you will. And now that we're done the nitpicking, let's just take a look at a couple of more useful or real world photos. Here we've got one with the A7R4. This is a 40-second exposure. I believe this is potentially, is this tracked? It is tracked, and it is defocused a little bit. Here we're going to look at what happens to the foreground. You can see here at 400% you can notice some motion blur on the mountains. Whether or not you would choose to stack the foreground is up to you. In this case, I think all things considered, it's pretty minimal. And that will be included with the samples as well, as will this photo here, which I took recently. Here we had a aurora storm happening. This pink bit in the middle here, this is called Steve. Yes, S-T-E-V-E, Steve. You can look it up. It's a odd type of aurora. Here we have Jupiter, and we even have the Andromeda Galaxy making a little appearance. This is with the Alpha 1, 50 megapixels, and 2.5 second exposures wide open at ISO 500. And again, you can see in the corners, we've got some of these aberrations. And in this context, I really don't think, if anyone's looking at the corners here, they're missing the point. But this is another type of result, and I will include that so you can pixel peep it as well. And I'm now going to play a time lapse that I took using this lens on a modified Sony A7R Mark II at ISO 640. Now, usually you're not able to modify the A7R Mark II, but I found a way around its particular quirk. And in this case, the color balance is going to be different than you would normally see. It's going to have more reds. It's going to look a little bit purple at some point. There's a lot of sky glow, but it's about 4 hours compressed into 40 seconds. I think those were 15-second exposures. So I hope that gives you another idea of how you can use this lens and the results that you can expect from it. So I hope you enjoy that. I hope you've enjoyed, or at least found, all of this information useful. I would really encourage you to get out there under the night sky as much as possible, regardless of what lens you're using or how you're doing it. Just experience the beautiful universe that we have on show every evening. And yeah, I'm not going to pester you to subscribe or anything like that, but if you are looking for some astrophotography gear, and we might have something for you over at ferventastronomy.com, by all means, take a peek. We carry William Optics, QHY, Fornax mounts, Astronomic, bunch of curated, boutique-y, admittedly higher end astrophotography gear. And if you're in the market for that, well, by all means, give us a peek. Anyway, that's the sales pitch. I've been Darren from Fervent Astronomy. Take care.